Hi, myself Susrinivas. I am here to discuss about my project, New York Taxi Fare Prediction based on the demand. Coming to overview, I will discuss about the introduction and then motivation and then dataset from where I downloaded the data, analysis using NumPy, Pandas, etc. different libraries, prediction and comparison of ML models, and then conclusion. Coming to introduction, more than 1 lakh automobiles are currently on the road in New York City, an increase of 63,000 over the previous several years. So this is like steep increase in the automobiles on the road in New York City. On the other hand, taxi trips have decreased from 11 million to 8.5 million annually, while the number of trips in app-based vehicles such as Uber, Lyft has climbed from 6 million to 17 million annually. This is like steep decrease in traditional taxi trips and then steep increase in the app-based vehicles. So by seeing all of these, New York Yellow Cab company consequently made the decision to focus more on data because they are facing more losses. So yeah, we need to coming to the motivation. So if you see from 1900 to 2000s, for booking a taxi or for taking a ride in taxi, we need to just be on road, just we need to get onto the road, and then we need to lift our hand to see which taxi is available right in front of. Taxis are like 1 minute or 2 minutes away far from us in New York City at that time, and then we need to just get into the taxi and then bargain with the driver about the fare amount, taxi fare. We need to just bargain, then we can directly move on to our destination. So there is no dependency, like we need to have mobile, internet, and then money in the card, like credit or debit cards. So but right now, if you see, there are no traditional taxis at all in every place in the world. Mostly it's like software based vehicles. We need to have our internet in place, mobile. So I mean, smartphone, internet, and then again, bank credit or debit card. So yeah. Mm, so there are advantages and disadvantages of this. Advantages on software based vehicles is like based on the demand, the fare price will change. But for traditional trips, there is a fixed amount between drop off and pickup locations, irrespective of the time and traffic. So the aim of this project is to predict the fare amount for taxi ride in New York City, given the pickup, drop off, and locations, time, and number of passengers for the pickup. I compared different machine learning models in this project based on RMSE value and found the best model for predicting the data. Machine learning models used are linear regression, decision tree regressor, random forest, like gradient boosting regressor. Motivation. Coming to the dataset, we have downloaded dataset from Kaggle. Dataset contains 2,29,569 rows and then 8 columns. Our target variable is taxi fare, which depends on several factors such as distance, time travel, number of passengers, and traffic. The evaluation metric for this project is RMSE value. As you know, RMSE value measures the difference between the predictions and then the real value. We need to filter our data set as to get better predictions such as fare greater than minimum ride of taxi, number of passengers, and the distance. These are the columns in our features in our data, like fare amount, pickup date time, longitude, latitude, pickup, drop of longitude, drop of latitude, and then passenger count. Coming to analysis of data, I have drawn histogram for fare amount and then passenger count. If you see, for fare amount for less than $20, there are maximum number of rides. I mean, maximum number of rides. So there are maximum number of rides for shorter distances. If you see for histogram of passenger count, there are more number of single cabin passengers compared to other numbers. This is the New York City pickup and drop off locations. The blue represents the pickup locations, and then green circle represents the drop off locations. This is the boundaries of the New York City limits. I mean, boundaries of New York City. So this is the map I have used. I mean, I have drawn this map using the Folium library in Python. This is the other graph. Like we have represented fair price changes in a week and fair amount taxi fare changes in a day. If you see the first graph, average fare hits the lowest on Friday and then hikes up on Saturday. Fifth is the Friday and sixth is the Friday. If you see average fare, it's lowest on Friday and then steep increase on in weekends, and then fare price changes in a day. Taxi fare has three peaks in a day. If you see 3 to 6 is the first peak, and then 13 to 16 and 23 to 2. If you see, fare tends to go up in after midnight, which could due to surcharge or of the fact that public transportations are closed, so commuters have to hire taxi instead looking for a long trip. Now we use Haversian formula to find distance between 2 points. The Haversian distance is the angular distance between 2 points on the surface of sphere. As the Earth is spherical, the Haversian formula provides a good approximation of the distance between 2 points on the Earth's surface with less than 1% error on average. Yeah. So this is the formula to find distance between 2 points. This is like nearer to the real time distance, real value distance. This is the graph between distance and the fare amount. If you see the relationship between the distance and fare amount is directly proportional to each other. As we know, if your distance increases, fare amount will get increased. Yeah, we have drawn for less than 100 kilometers of distance, then fare amount. Yeah. Coming to predictions and comparison of models, we have used like 5 models, right? Like linear regression, decision tree regression, random forest, like gradient boosting mission, gradient boosting regressor. Of all these models, linear regression is like given like 4.882 RMSE value, and then decision tree 5.164, random forest 5.773, like gradient boosting mission 4.120 RMSE value, and gradient boosting regressor given the least RMSE value of 3.648. So by this we can say that gradient boosting regressor is the best model to predict our data. This is the prediction of fare amount by taking the distance into account. Uh, if you see for distance of 8.4 miles, the fare amount is 24.39, and the distance of 2.5 miles, fare amount is $13. Distance of 14 miles is like $31, and the distance of 1 mile is like $6. Distance of 1.8 mile is $6.84. If you we can see that maybe $6 is the minimum. Like for 1 mile, there is a minimum charge of $6, and then distance then distance increasing, the fare amount will get increased. Finally, into conclusion, we have compared the different machine learning models using RMSE value and determined gradient boosting regressor is the best model for predicting the taxi fare based on the demand. And also we have calculated distance between pickup and drop off locations using Haversian formula, which is very important nowadays to use in navigation. That's it, guys. Thank you so much. Have a good day. Thank you so much.